To finish up this module, we're going to have a look at a seasonal sales data set. 5 seasonal sales, is it? Change the name to seasonal sales and run. Then under tasks and utilities, we're going to do linear regression on the seasonal sales data set. Dependent variable. Actually, we should go back and have a look at the data, yeah? And it was up here. Output data. Let's change the size a little. Okay, so here is our data. We have sales data, quarterly sales data. We have a time trend variable. We're going to use that to capture the fact that sales might be increasing or decreasing across time. We have quarter variables to reflect the fact that some particular quarters of the year might have higher or lower sales than others. We've got the number of competitors. 3, 2, 2.5. That looks a little weird. How can we have 2.5 competitors? I'm pretty sure that what happened here is that one of these competitors went out of business halfway through the quarter, and so it got coded as 2.5 competitors. We've also got individual dummy variables for quarters 1, 2, and 3, with quarter 4 being the omitted category. We won't need those because SAS Studio is happy to work with this quarter variable here. Okay, so now going back to our linear regression, our dependent variable, the thing we're trying to predict is sales. We have a classification variable, the quarter variable, and we have 2 continuous variables, time and competitors. Okay, let's make sure these all end up in our model by hitting edit and entering each of these in as single effects. We'll click OK and then run our model and see what we get. Okay, so what do we get? Well, first off, we have a model that is significant overall. Good news. Probably unrealistically high adjusted R squared, but good for us. We've got a nice fitting model. Okay, we've got a nice fitting model, so let's take a look at each of the coefficients. Time, very significant. So we can estimate, we can interpret its parameter estimate. How should we interpret this? Well, that says that every quarter, on average, sales go up by $4,134. Neat. What's next? Competitors, very significant. P-value much less than 0.05. And what is this? It's got a parameter estimate of minus 77,756. So this is saying as our number of competitors goes up, our sales go down. Each extra competitor decreases sales by 77,756 on average. Alrighty. So now let's turn to these quarter variables. The quarter variables are a little tricky to interpret. They're all estimated with reference to quarter 4. And so we should interpret each of the parameter estimates as being how that quarter's sales differ from quarter 4 sales. So our first one here, quarter 1, has a value 36,791. This is telling us that sales in quarter 1 are about $36,791 more on average than sales in quarter 4. Quarter 2, we've got a minus 22,000 coefficient. This is saying that quarter 4 sales on average are $22,696 lower than quarter 4 sales. Quarter 3 sales, we've got a coefficient of minus 10,000 odd. So quarter 3 sales are about 10,000 lower than quarter 4 sales on average. But as we look over here, we've got a bit of an issue, right? quarter 1 and quarter 2 have these significant p-values, but quarter 3 does not. What should we make of that? Well, what we should make of that is, well, we're just not done. We don't know if these quarter variables are significant or not. We can't just look at these individual tests. We have to look at quarter as a group of variables. This is a group of variables that we should either have all of or none of, because in advance we have no idea which of them we would want to include. That means that afterwards we can't start taking them out individually. We have to either have all the quarter variables in or none of the quarter variables in. You can see a little bit of description of that on Blackboard as well.